Okay, good morning, and welcome to the Security Education Panel. Thanks for joining us pretty early this morning. Today we're going to cover a wide range of topics, from developer and student education to CTF competitions and diversity in computing. We'd like this panel to be interactive, so please come up to the mic in the center as soon as you have a question, even right now if you already have a question. I'm going to kick off with some introductions and a couple of questions, and then we'll make this interactive from there. So with me today, I have Justin Cappos, who's a professor at New York University. Justin and his students focus on solving real-world security problems in practice, and his team's research has been productionized by Docker, Git, Python, VMware, and a bunch of other companies that I won't list here. I'm also joined by Matt Bishop, who's a professor at UC Davis. Many of us probably know Matt because of his book, which we probably had when we were in undergrad or grad school, Computer Security, Art, and Science. Matt also co-chaired the joint ACM IEEE AIS SIGC IFIP Task Force on Cybersecurity Education, which developed curricular guidelines for cybersecurity. And finally, I'm also joined by Douglas Szajda, who is a professor at the University of Rochester. Douglas has been teaching computer security for the past 30 years and is unique to our panel in that he teaches at an undergraduate-only institution. So he has a little different perspective than some of us who also have PhD students in our universities. So to get started, I'd like to ask our panelists to tell us where they think security education should be taking place. Should it be exclusively in academia? Should we be trying to teach everyone what they need to know before they get out into industry? Or once they're in industry, should they be getting specialized training on the specific security things they need to know, rather than sort of getting a brain dump when they're in school?
Thanks. So I'll go ahead and take this first. So first of all, I think our keynote that we had really underscored on the first day, there's a big gap between academia and industry. And I think that is something of a shame. I think we need to do what we can to educate students and make them prepared to do the real world sorts of things that they're going to do when they go out there. That doesn't mean that we need to be sort of a tech training school that rather than teaching a networks class that tells them the fundamentals, is teaching them how to set up Cisco routers. But I think that the things that we do and we reinforce need to reinforce those practical real-world things, which is why when I teach, for instance, we'll do actual security audits of startups and things like that we'll have come in and present. And we'll do things like work to fix bugs in Debian, fix security bugs in Debian distributions or Arch Linux or other things like this as part of it.
I think the security education actually needs to be in both. And I very much agree with what Justin was saying, that in academia, you're teaching primarily principles, fundamentals, that sort of thing. But if you can use real-world examples to support those, for example, how to configure a Cisco router in networking and so forth, that adds a lot of value for the students. But each industry, in fact, each company, in my experience, has its own unique requirements. And so to plan a program that would allow someone to walk into a company and immediately begin doing security would require the program to know very much how that company is working, what their security setup is, and so forth. And that's not really something that that we can do in the period of time that we have the students. But what we should do is give them the foundation so that they can walk in and very quickly learn that stuff. And if the company changes something, for example, they can build on what we've taught them in order to make the change relatively painless instead of having to start over from scratch.
I'm going to largely agree with the previous two speakers. Richmond's a liberal arts university. So when we teach any computer science, we're thinking we want to teach them fundamentals, principles that they can take with them and use throughout their career. If I teach them some technology that may be obsolete in 5 years, then we really haven't done our job. And I'll also agree with Matt that every industry has its own requirements, and we couldn't possibly train our students to be prepared to walk in on the first day and go right to work using these technologies. We couldn't fit it in our curriculum, especially since being primarily undergraduate, they're going to be taking lots of other courses. So their security course may be one of 10 courses they've taken in a year.
Thank you. Another thing that's been popping up is that there are a number of boot camps emerging for mobile development and front-end development, and sometimes these are seen as being a little bit in competition with the traditional sort of university academic model. So I was curious whether you see a future for cybersecurity or privacy boot camps, and if you think that's a good thing or something that jeopardizes maybe the traditional sort of four-year education in computer science.
I think it's definitely a good thing if somehow someone is able to, in, I don't know, a few days or a week, like teach enough that somebody can be a competent security professional, then I'd really like to see that. For me, I've gone and done a lot of these types of things, especially, for instance, outreach to high school girls or other underserved communities. And just getting them to learn how to open combination locks that they have a legal right to open, but they don't know the combination to, or other things like that, is just, I don't know, kind of opens a new world for them, and they start to look at things in a new way. So I think they often build more excitement and give a thirst for more rather than as a completion of a journey where you end up with a trained professional at the end.
I think that the two are actually complementary. The boot camps are week-long programs that typically teach something intensively, like writing mobile apps and such. And in a week, my own experience is you can't really get to the fundamentals underlying that, but you sure can get the kids curious and excited about doing it. And in many cases, they go on to take courses that will show them that. So I think the two are quite complementary, and I very much agree with what Justin said, that sometimes it opens completely new ways of thinking. California has something called the Cosmos program, which deals with high school students, and we've done that a couple of years, and the excitement on the kids at the end was absolutely wonderful. They also got tours of security companies and such. So I think there's a place for both of them, and they're complementary.
Yes, Richmond in particular has a couple, I don't mean university, but I mean the city has a couple of things. We have Code RVA that are like camps that teach not specifically security, but teach computer science. We have Capital One holds events that can be a week long they can focus towards general audiences or toward underrepresented groups. But in either case, I think I love having students who've been in them. Primarily because when I lecture in class, if they haven't seen certain things before, then they don't know why I'm teaching them something. And yes, it's my job to get across to them, this is why this is important. But if they've seen something in one of these camps and they know what they're working toward, it reinforces their learning. It really helps them say, I know where this is going. I know something of where this is going, so I really do have to know this, as opposed to, will I ever really use this?
Right, and one other thing that jogged my memory with some of this is that we've also started to move to a model where even people that have graduated out of our program or things like this, as new technologies or new techniques or new security relevant things come along, they can go back and take modules and get a couple days worth of education on some new topic or some, hey, Kubernetes security wasn't something that anybody cared about 5 years ago because there was no Kubernetes. Right, so people coming out of our, of our program can kind of take almost these mini boot camps and things like this to keep their skills at a very high level. So I think that also has a role to play in the ecosystem.
Thank you, and feel free to come up with questions if you have them at any time. So we heard in the invited talk yesterday from Arthur Jans about developer education, and we've heard a lot about developers not setting parameters correctly, developers doing X, Y, Z kinds of things. And I was curious whether you think this is maybe a case of developer lack of empathy, where they aren't thinking about what might happen to users. Is it a case of developers just not having the skills when they come out of school? What might we do to fix these developer problems that we keep hearing about?
I think it's difficult, and I don't think there's like the one true magic bullet. I think that the recipient of the bullet is always the developer, but I think that's often unfair. Because a lot of times it's like the language designer or the people who wrote the libraries or things that put the developer in a position where it was easy for them to shoot themselves in the foot, or where there's a big shortage of people, and so you have a lot of people that maybe haven't had any formal training going and writing code in certain languages like PHP that causes a lot of these issues. But I think it's difficult. I wouldn't. I don't know that there are many developers that go and say, I just want to do a crappy job and I don't care about security. But there are pressures and other things that happen, and everybody makes mistakes.
I think the pressures and such is a very good point. I also think one of the issues we have in academia is in your first programming class, you're taught how to program, check for errors and things like that. But as you go on in your university career, the emphasis is much more placed on getting the right answer or writing the algorithm correctly or that sort of thing, and not so much, well, what happens if the input is bogus? And so I think continuing to focus on that and emphasizing it would really improve things. We've been doing a project funded by NSF called the Secure Programming Clinic, which functions like a writing clinic. And the measurements that we're taking show that it does improve things, providing the class emphasizes that, says you have to use this, part of your grade depends upon it. That said, once you come out and go into industry, often the pressure is not, well, let's build it very safely and securely. It's, well, if we're not first to market, we're going to lose our market share, so let's get it out there now and we'll fix it later. And at that point, the problem becomes, how do you get the students who know how to do this stuff, how do you give them the support to apply it? And quite frankly, that's an answer I don't know, given the marketplace and the the computer environment. I wasn't going to say cyber, but I understand that's a synonym for cybersecurity in a lot of places. One other comment which Justin made about the burden falling on the developer. I've heard a lot of talk about, well, we have to certify programmers. That's my big complaint about it. Because when the programmers are certified, if something comes out that they've written that's bad, then they're the ones who are in trouble, not the people who did the support libraries and such, and not the companies that are putting pressure on them. So if we're going to certify things, I would really rather see the companies certified as opposed to the individuals. So that way, everyone has a stake in the game, so to speak. Everyone has a requirement that they do things well and that they support the internal people who are trying to do things. So
I start with saying what I think both of my colleagues said was, development is difficult. So it's not, we make it sound like it's this easy thing. If we educate people right, they'll do it well. And all sorts of studies have shown that even the best coders are going to make a certain amount of mistakes, every 100 lines of code or 50 lines of code. But you both talked about pressure, and I'm thinking back to my first time coding commercially, where my manager came to me and said, you have 3 weeks to build a prototype that works. Don't worry about the bells and whistles. Just make sure it does X, Y, and Z. You'll have time to polish it up and fix the code and do it the right way once you have a working prototype. And when the 3 weeks were up and I handed them the working prototype, he immediately said, well, now can I clean it up now that I've written it? I know how I would do this better. No, we need this, and this. So it never gets cleaned up. And so, as you were saying, the coder gets blamed if coders are certified, but there's an environment that is encouraging you to just throw something down that gets the right answer, even if it's not secure, even if there are vulnerabilities that the coder themselves may not know about. And I don't see how you address this given the market forces. I understood why they were asking me to do that. Get it to market fast.
Thank you.
One other point. Often the security requirements are not clear at the time the program is written. And so you'll write the program to do one thing, and then someone will discover, well, wait a minute, if we move it into this environment, all of a sudden it's going to work very well here. Not understanding that that environment has certain things that the requirements for this environment cannot satisfy, and so the program doesn't work right. So that's another issue with development.
Thanks. Yeah, go
And
ahead.
actually, often the security parameters are non-existent.
Yes.
The first couple of questions were regarding education, but it focused on the college level. What do you think about K-12 or even before K-12, and what should be done at that level?
Oh yeah, that's a great question. Thank you very much. I think that you absolutely can spark excitement and get people interested in things. I've found that a lot of the same physical security type exercises that I do for, in the first week or so to get my students interested, even master students, work very well at the high school level. I think also a lot of discussion around the technologies that people use in their everyday lives, like Facebook and those tracking devices that everybody except for me seems to carry around, that listen to everything you say and know where you are and call you cars and stuff like that. But just talking about those devices and how they use them and what their usage patterns means, I think also helps people to see the world around them and to really sort of connect computer science and computer security to their world in a way that otherwise they was just this invisible force behind the scenes.
Yes, with K-12, I'm not real sure what you could do at the kindergarten level that would be specific to computer science, but certainly at the higher grades in high school you can. One of the things I've found is they love to break things. So showing them how failing to check for bad inputs or things like that work generally gets them laughing and very much interested, and then showing them how to fix it or how to do it right does as well. Also, exposing them to strange problems works well. The one thing you have to watch out when you do that is Googling. In our Cosmos once, we gave them a problem to basically write a program that printed itself. And it was amazing that most of the students very quickly started Googling, but one person started writing and actually did it on her own, which was very impressive. So
I have a daughter who started doing computer science stuff. She's 14 now. It's just starting high school in a couple of weeks. But she started doing some type of coding via Scratch and things like this, I want to say about 6 years ago. So I think introducing kids to computer science concepts when they're young is great. The problem I've seen is that it's just hard to find qualified people to do this. My own experience, I have another son who's a senior this year, and he took a first real AP CS course last year and was learning Java. And I looked at the assignments and I thought, I know this teacher is well-meaning, but these assignments are obscuring what he's supposed to be learning. They're teaching about loops, and instead he's getting bogged down in the GUI stuff that they're trying to do to make it fun, and the real actual part of the code that he's supposed to be learning is just 3 or 4 lines. The rest of it is all making the GUI work. So, it's hard to find science teachers at for K-12 science teachers. It's really hard to find people who can teach CS. And while I may have some issues with the particular teacher, who, as I said, I think overall he did a good job, until about 4 years ago, there were no CS teachers or no CS courses in our entire county, and we're one of the best. They're consistently ranked one of the best in the country, but there were no high school CS courses. So it's hard to find people to do this.
By the way, I'd like to clarify one thing I said. I said it's rather hard to teach kindergarten students and such. I should point out that some students seem to innately know this stuff. For example, one of my children who was about 3 years old, we had a babysitter come over because we were going out. And so when I came back, the next thing I knew on the desktop, there were about 80 folders. And a game that he liked to play was bury 20 folders down in one of those 80 folders. granted, that's not real security in the sense that it was very easy to figure out, but at least he had the right mindset of trying to obscure things. So sometimes you can have fun like that.
Great, thank you. And I wanted to welcome Raheem Beyah, who's also joining us. He's a Motorola Foundation professor in the School of Electrical and Computer Engineering at Georgia Tech, and he's also the executive director of their online Masters in Cybersecurity program. So if you have online education questions as well, he would be happy to answer them. Tamara, go ahead.
So I've definitely heard some people talk about the fact that it's unfortunate that our approach to teaching security in undergraduate is like there's an elective near the end where you kind of throw a blob of security stuff after they've, been learning all along. So some people say that the way to go is to try to sort of integrate at least a number of little modules, depending on the size, not the technical meaning of module, along the way as students are actually learning to code. And you see some projects that are trying to build repositories of these kinds of things. I was wondering your opinions on that, and if you've had any personal experience seeing that done or trying to do that with others, and any things like that.
Yeah, so I think it would be great to have this integrated more. And I've created a bunch of security materials and modules that have been used by other people, including one program that did try to integrate it. Some of this, they tried to integrate it into CS1, and I think that was too early. That was basically their feedback. I could see this working well in other programs, but I'm interested if anyone else has firsthand experience doing that.
So yes, at Richmond we do introduce security, and I don't want to say that we have, for example, sections in our CS1 course where we talk about security. But when I'm teaching Java or Python or whatever I'm teaching, I will be talking about issues. I'll be talking about one of my pet peeves is opening a textbook and seeing that you declare the type of a variable so you know the size of the memory you need to store it. And I'm like, no, there's so much more to it. And so we talk about concepts, and primarily because the security course is offered once every 2 years, and a lot of students won't take it. Our purpose isn't so much to teach security as to make students who will maybe go out and become developers aware of the issues that are out there and how a simple mistake can cause all sorts of problems. For example, in my networks class, I leave an originally unintended buffer overflow in a project, and I could have fixed it, but I left it there years ago because ultimately what happens is a lot of students end up overwriting one of their own variables without realizing it. They perform a buffer overflow on themselves. And that lesson, that sticks with them. It's like, oh, this is this thing that can happen, and I need to be aware of this when I code. So it has been successful, at least at raising awareness that there are issues beyond making your code work that are really important.
So it sounds like that's something that sort of you personally do awesomely in your course rather than like an incentive across the whole program, the undergraduate program?
So awesomely isn't the word I would use. Maybe adequately, semi-adequately, mediocrely. But it's not just me. I think generally I'm the one that focuses on security in the department, but my colleagues are very aware of these issues. And in fact, several of them have been to USENIX in the past, but even though they're not security people. So it's a really across the board issue that we want to be aware of this. But it isn't, and I want to stress, it's not there's a module in this course. When I'm talking about architecture, or when I'm teaching architecture, I will be talking, as issues come up, I will be mentioning this is something that's important for this reason. So we make them aware of it. I would only have anecdotal evidence as to how well that works once they get out.
Yeah, I'll make a general comment, and first let me apologize for being late. One other role that you probably don't even know about 2 months ago, I was crazy enough to accept one of our vice presidents for research roles at Georgia Tech, and what I found is often there are various size emergencies that require attention, and I had one of those this morning, so I apologize, even though I got here 24 hours ago. I apologize for coming in late. I I like the idea of integrating security essentially in every course, or mentioning it in every course, because I think it totally makes sense. But what we found, and I'll be honest, at Tech, is that most of our security faculty usually shy away from the lower level courses. They're usually focused on graduate courses and sort of senior level security courses, and that leaves other folks who are teaching our intro level courses who they appreciate that security is important, but they also have many other priorities that are important to them as well. So it's not as important as us. So if I were teaching an intro to programming course, I would certainly mention that and do a little module on security. But unfortunately, our colleagues are not, because they're focused on so many other areas that are priorities for them.
Thank you.
One quick comment. At Davis, we have a strong security program, and what that means is a lot of faculty collaborate with us, and a lot of them we have joint grants with networks visualization and other groups, and what's happened is that those faculty have integrated some security into the courses they teach. It's again, like Douglas said, it's not a module or anything like that. It's just an awareness running throughout the course. And I think, quite frankly, that's the best, that seems to work very well. One other comment, robustness, which is a really component of security, although it's not really that often talked about, is something that can be integrated into almost any classes. Our lower division ones do that. They don't talk about security principles or things like that, certainly not in that context. But it's more like watch your inputs. In the networking class, I know they talk specifically about security. I believe they do in the architecture and a couple of other classes. But again, the emphasis here is on integrating it throughout the course, not, by the way, here's everything you need to know about networks. Oh yeah, and let's talk about security.
Yeah, hi, I'm Dave Balancin from SRI International. I want to build on the question Ann asked earlier. This also relates a little bit to the previous question, and it's actually three questions, but they're part of a theme. So there's a lot more to computers than just science. So I'd be interested in knowing not just K through 12, but what do you see as the role of vocational schools? Also, the multidisciplinary aspects of computers, and in particular, computer security and privacy. So dealing with business, legal, economic, behavioral, social aspects. And then maybe, Matt, you could talk a little bit about the CSEC and how it addresses some of this, and I'd be curious to hear from the others what they think about CSEC. But in short, computers are part of everything, and we can't just teach the science and security in the context of computers. We got to teach it as part of everything, just like computers are.
Okay, let me take the CSEC one first. CSEC has 7 knowledge areas, 4 of which are generally technical, 3 of which would be seen as non-technical: organizational, societal, and human. And in CSEC, in each of the knowledge areas, there is what we call basically learning essentials, which lists several things that anyone studying security or anyone who's dealing with security should know. Now, CSEC does not say you must teach A, B, C, and D. What it says is, here's a smorgasbord. Pick out what you want to pick out what you think would be most valuable in your course, and then teach it however is appropriate for your course. And we're getting instantiations of this that are going up on the ACM website. But throughout, one of the things we were most aware of was that you have to teach security, or you have to deal with security in law, in medicine, in business, even in the humanities. And so the focus of CSEC is broad enough so that, for example, we would not expect a lawyer to be able to do a buffer overflow. It'd be great if they could, but it's not normally part of legal education. On the other hand, we would expect them to know, well, how are vulnerabilities endemic throughout software, and what can happen as a result, that sort of thing. But again, it's really up to the individual instructor. The CSEC is 2017 or cybersecurity curricular guidelines, and the emphasis is on guidelines. It's not prescriptive. In terms of the other questions, we've again, I know that they're taught in various courses elsewhere, but from a very different point of view. And I agree with you fully, it needs to be across a large part of the curriculum, many different disciplines. Also in part because a lot of web developers and such come out of art or the humanities. And if they have never seen attacks or never seen how to program to prevent those attacks or to handle those attacks, good luck.
So as I'm listening to this, I'm struck by the thought that it's not just security. You're right, there are a lot of other things. And in fact, I teach a sort of 3-day transition course for incoming first-year students. It's sort of to introduce them to college, and I teach it on data privacy, and it's not technical. It's, that picture of you jumping off onto a pool table in your fraternity house in the backyard. Your employer will see this 5 years from now and enjoy it. And there's things like this. But I'm struck by the fact that we live in a time in computer science that's really interesting in that we can shape the curriculum, but we're still, even forget about security. Think about just computer science. What should be in a CS1 course? We're not like math, where calculus, you know how to teach calculus. You know what's in a calculus course. You know what the sequence of things will be. What should we put in these courses? I'm not sure we've figured out the technical part that should be in these courses, and now we've got this whole other aspect of machines that, as we've seen, influence society in ways that can be completely unintended. I don't know how you possibly manage all of that, especially not in a CS curriculum.
I'll comment briefly because we see you got a nice queue that's forming. So 2 things. I completely agree as far as vocational piece. The worst thing we can do is keep our knowledge at this conference. That's the absolutely worst thing that we can do. So I think we have to push it down, if you will, to make sure it's much more accessible. So high school, vocational, et cetera. As a matter of fact, a lot of the demand that we're seeing, a lot of the shortage in the market is not from folks necessarily graduating from our program, which we think is great, this MS in cybersecurity, but it's really associate degree type folks, folks with undergraduate degrees in security or related fields. So completely agree. Also agree about the interdisciplinary piece. So Tech has had this MS in InfoSec for about 18, 19 years, which, we've been doing it, before it was cool. So I was like, oh, everybody wants to do a degree in this. But about 5 years ago, we got really good feedback from one of our external boards, which is like, security is broader. It absolutely is. We knew that, but thanks for telling us. And they said, do something about it. So we created a new degree, MS in cybersecurity, that actually is inherently interdisciplinary. So it has a policy track, energy systems or CPS track, in a traditional InfoSec track. And what's nice is that those folks actually intermix in the first 2 courses, and they also intermix or intermingle in the practicum as well. So I completely agree. It should be taught broader.
Great.
Thanks.
All right, thank you.
Hi, I'm Nick Weaver. I teach at Berkeley, among other things, both the lower division computer architecture class as well as the upper division computer security class. One thing that strikes me is, how do you teach C? So in the computer architecture class, we have to teach C because you have to understand how the computers work. But at the same time, I personally, when I teach the class, make a point of making sure that students understand that unsafe languages are basically literally AK-47s tied to point at your foot. And I have the continual mantra of, what does this do? Undefined behavior. Get them to realize that undefined behavior is the root of so many problems. Not just security, but it's your bugs. It's the Heisenbugs. It's all that crap. And so I'm wondering if other people have been trying to make a systemic effort to get people, especially on C and C++ and the other unsafe languages, to understand them, to respect them, and to loathe them with a passion by the time you're done.
So one thing we do in our application security sequence is we have the students implement something that's meant to be a fairly simple program in an unsafe language, something like a conversion program that converts English text to Pig Latin, or does something like that. And then we also give them some kind of glue code around this. So it's part of a module where they go through and first they build a local app using something that would run as just a normal desktop app, using the normal methodology where we give them some of the plumbing around that. Then they convert it to a web app, and then they put a database back in, and then they do cloud, and then they do a mobile part. And all of those pieces, we give them a bunch of plumbing and framework and talk about and show them instances of where they have exactly the types of problems that you're worried about. So the issues that you're worried about related to C, we cover and go through and have given them code and things that will have those sorts of problems as part of their framework. So they get, they may have introduced bugs like this on their own, but they get this really visceral understanding of why they need to, like bounds check operations, and why they need to use safe operations, and why they need to not have undefined behavior, and so on.
Or just don't use fracking C.
Right. Well, it's used a lot of places, and at least our approach is, we show them how in that framework they're going to encounter problems using it in this way, and then as they get to other languages and frameworks and do things, they don't have to encounter those problems. They get all sorts of fun new problems that are reasons for them not to use other languages as well. So.
One of the things, to speak directly to the uncertainty or to the undefined, one of the things I've done in the past, and I teach an introductory C course, is to have the students implement programs that specifically use undefined behavior and have them run it on multiple machines. What happens in that case is they, wait, what? It worked there. And so then they learn, A, don't do that, and B, if you have to do that, make sure you check that the machine you intended for is the one you're actually running on, and things like that. I do warn them about type unsafe languages as well, but I agree with Justin that C is used very, very widely, particularly in the communities I work with, and so saying don't teach it wouldn't work.
No,
I
I'm
suspect.
not saying don't teach it. I'm saying teach it in such a way that no student will willingly start a new project.
What can I say? Students tend to use the languages that they like, that they're comfortable with. But if they certainly learn the difficulties and the problems in C that aren't, for example, inherent in Python. Python has its own problems. So I guess that's about the best I can say.
And I also say that it's very rare that a student going into a company is going to start their own new project and be able to pick the language. But yeah, anyone else want to add something or?
Hi, good morning. Luca from TU Eindhoven in the Netherlands. So far we've been talking about how to educate people to build secure software, be security aware, but we're also being in a pivotal moment, right, where the figure of the hacker is being professionalized now. So teaching people how to offend is part also of some of the security curriculums that some of our universities want to teach. And this is, of course, a tension with ethical aspects and other things that, especially in engineering schools, as opposed to more art and humanities schools, are not, part of the natural interest of the students. So the questions to the panel would be: how do you see offensive technologies being added to computer security curricula in general? And how do you think the ethical aspects should be appropriately addressed?
I think that there's nothing fundamentally unethical about offensive technologies. There are a lot of excellent groups that do penetration testing. Trail of Bits and a lot of their graduates came out of our program and worked very closely with us. And pen testing, even, we have classes where we do offensive security to teach students how to do penetration testing and do these other technologies. So I think if it's done right and you show them the right way to do it and you talk about, you're not just going to go and start trying to break into every mom and pop website that anybody set up on the internet. I think it's an extremely valuable skill, and actually one that a lot of our graduates get hired to do professionally. And I think that in general they help the internet security greatly by doing so.
Yeah, I don't think, I mean, arguably, my opinion would be you can't teach someone how to defend a system unless they know something about how it's going to be attacked. This being said, I did not enjoy one of my students doing a spoof some years ago, a simple one, whereby my class received an email from me canceling my final exam. So.
Yeah, I completely agree. I mean, I've heard that. You know, I've given lots of presentations in front of our various advisory boards, and whenever we talk about doing some sort of offensive stuff, it's like, oh my God, you're teaching these things. And my response is absolutely yes, we are. And you cannot defend if you don't know how to attack. We absolutely have to do this. And it's foolish to think that if we don't teach it, they won't learn it. I mean, it just doesn't make sense. So this is a great opportunity for us to teach this, but also bring in the ethics. So actually have them learn it the way we want them to learn it, because that's part of defense now. I mean, a pen testing job is a legitimate and very useful job. So I think it's really important to consider that.
Yes, I'd like to hammer home on the point of ethics. When you teach this sort of thing, you really need to hammer into the students. There are rules, there are things you can do, and there are things you can't do. And also, make sure you get things in writing. Also, in terms of teaching offensive security, I too teach penetration testing and such, but there's also a flip side to it, namely, how would you prevent this from happening? And typically that's done with existing systems. And then the next question is, how would you build a system where this couldn't happen? So in other words, instead of focusing on defending the current, also try to look ahead and say, well, can we build systems where the threat on existing ones is not really a threat there because of the way we've designed it? One of my pet peeves about capture the flag contests, which I think in general are great, are that I'd like to see more focus on building and designing and building things that are secure rather than attacking things that we know aren't. Pet peeve, though.
Thanks. Thank you. Next.
Hi, Cynthia Irvin, Naval Postgraduate School. So in my world, my world started thinking about computers pretty early, but there's a definite realization that we have land, air, sea, not in the order that they've been deployed, and space, and now the cyberspace, which is a human artifact. So starting with that is sort of where I'm coming from. I have two questions. One is, our technology is still accelerating and moving forward very quickly, and there is increasing automation, and that includes automation of IT functions that may involve security, where the human is maybe outside of the loop and looking in to make some final decisions and configure things, and the generation of software from specifications by artificial means. And how, this is question number one, how should our education enterprise prepare for these changes, which are in fact on their way? There are people who are predicting that there are not going to be as many people writing software, that the computers are going to be writing software. So how do we change our computer science programs to deal with that? And I'll let you answer that and then ask the second question.
That's a tough one.
I'll take a shot at it. The first thing is the automation. While I think it's great, also concerns me a bit, because when the computer says something, people see it typically as infallible. What happens if the specifications from which you're building the program aren't the correct ones? So I think there needs to be a human in the loop somewhere. That said, the programs and such to automate the development of software, at least in my world, I haven't seen much of that. And as we see more, I expect we'll start integrating it into the courses. But I'd also like to make the point that even if something is automated, people still need to understand, the people who are working with it should still understand how it works, not so much necessarily how this, things are generated, but the end result. They need to know where the flaws might be. They need to know how to come up with the requirements and so forth so they can build the specifications and maintain the tools that translate the specifications into code and do the testing that's appropriate. I'm not sure how I would integrate that into the program. Probably the students at first would love it because they wouldn't write much code in my security class. Then they'd hate it because they'd have to write specifications, which means they'd have to learn a specification language, which probably they would not enjoy, at least not at the beginning.
Let me just throw in, I understand, having been here for a couple of days, that there are people who don't understand how some ML applications are actually doing what they're doing. So how it works?
So this was, as Matt was answering, I was thinking just this, that of course there's this argument in ML of understanding how certain models do come to the decisions they do. So if you believe that in the future software is going to be creating software, or we're going to be artificially creating software, I imagine that curricula would have to change so that you would start by educating, or at least educating as a part of your curriculum, that students understand how these models are making their decisions, how they're deciding what software to write, what are the ramifications of this. I don't think we know the answers to that yet, but I also agree with Matt that I don't think that you're ever going to, or I'll back up a second. We have Mathematica that does a lot of things. That doesn't mean you don't need people who understand how calculus works. So I think there will always be a need for software development experts, even if software is writing more software.
Yeah, and I just want to piggyback one more thing onto this, is that you can also view the fact that we use, I don't know, languages that are not assembly, and the fact that we use libraries and things like this as the fact that we, as programmers, have already been automating away a lot of the mundane tasks that happen here. And so I would be quite skeptical because there's a lot of ambiguity left in what people are doing. Things that you can optimize away, better languages, better frameworks, Ruby on Rails and things like that come along and automate away a lot of the boring, parts that could have been automated by a machine. So there's going to be things in the limit there, and I am not at all worried about my students not having jobs for that in this part of the world.
Okay, so my second question has to do with the larger community. There's been a little bit of touching on K-12, but since we're dealing in a world where there is essentially a different dimension, human-created dimension, where is our Neil deGrasse Tyson person who is explaining this to the public so that they understand how cybersecurity and these automated systems are going to affect them, and so that there is a internalization of the importance of getting these things better, so that you don't eat tainted software. We try not to eat tainted food and drink bad water. So how do we protect this dimension?
So I'll start with this one. So I think there are a lot of us that do this kind of outreach. So Nick Weaver, who asked a question.
Yeah, but you're not Neil deGrasse Tyson.
No. But maybe we haven't had that charismatic person come along, but there are a lot of us that have been doing this outreach. I see Nick mentioned all the time in various publications. I've been on television like 60, 70 times and given hundreds of interviews about different things related to cybersecurity for different venues. So there are a lot of us that value and do work in that area. But, I would just say that it would be nice to have someone like that come along. So if you know anyone at like the Late Show with Stephen Colbert and can get a booking, then I think there's a lot of people from our community that you could recommend that are already doing that kind of public outreach.
Basically, until that gentleman or gentlewoman comes along, all we can do is small incremental steps. For example, with electronic voting when it first came out, anybody who opposed it was a Luddite. Because of course the computers are going to be accurate, and we're election officials, we know how to run an election. That mindset has slowly changed in many, many parts of the country due to the work that people have done, not just the technical work of showing the problems, but also convincing the election officials, look, we're not after your jobs, we're not saying you're incompetent, this is just an area that everybody needs to learn a little more about it. You need to learn the technology, we need to learn how elections work. And now, with the exception of a few states, most election officials happily accept the help of technical people and in many cases encourage it. So small steps until this person comes along, and I hope the person comes along soon.
So actually, I like the question, and I think it's a really good one, and I think we need that individual. I would even go a little bit more junior and ask, like, where's our Smokey the Bear? And I'm dating myself a bit. Half of y'all don't know what the heck I'm talking about, but it's you know, and that's something that we all know is this, you know, this campaign that you grew up on and you appreciated exactly what the message was. So it's even from 5 years old or 4 years old, we should be talking about these things and reinforcing them from a public perspective. Just 3 days ago, my 12-year-old daughter sent me a screenshot. Hey, Daddy, this popped up on my iPhone. What should I do? Don't click on it. I was in the middle of a meeting. Don't click on it, whatever it is, and we'll talk about it later. But she didn't know what to do with that.
But she did know to ask it.
I know. I'm excited about it. Now, I don't know if she clicked on it first and then told me, but.
Thank you. Go ahead.
Good morning. This is Ashish Kundu. I'm from Head of Cybersecurity at Neuro.ai. We make autonomous cars. I was at IBM TJ Watson Research Center before that. So I have a couple of questions from both of these experiences. One is about when we interview people, you know, what we have found even from PhDs from top schools, top CS programs in US and UK and other places, there is a gap in their understanding about security. It's important to understand holistic security because the weakest link is important to know. And people who come out from top programs with great publications still have that issue. And I like distinguished professors like you with Matt there also, to see how we should address that. And I'll come back with my second question.
Okay, I guess I'll kick this off. So I think if you want people that have really good security awareness and things like this, you're probably hiring in the wrong place for the most part if you're looking for PhDs. I think that most students that come out with a PhD become very specialized in a sub-niche that's not interesting to anyone in the world other than the 8 academics who review the papers that all publish each other's work. Just to be totally honest here. And by the way, I did a survey a little while ago that I sent to a bunch of professors in academia and also to a bunch of folks in industry, asking them very basic questions like, like 4 choices, like what is Multics? Which one of these 4? Is it an operating system? Is it a name of a band? Is it whatever? And the same with questions about like etcd and Istio and other highly relevant industry technologies. And the academics did very badly on the industry relevant technologies, and the industry people did very, there's this huge difference here. So I think especially, and by the way, the effect was much more pronounced as people became professors and had spent more time in academia. They knew less and less about what was actually relevant in industry. So there's a big gap here. And this, by the way, I think is a big problem. So if anyone's interested in reading this post, seeing all the data and stuff like that, you can type NYU space SSL. That'll take you to my lab site, and you can click on the blog there, and the top post there talks about it and has the data linked and everything else like that. So I think the right place for you to hire for the thing that you want is actually usually out of the master's programs. The students there will have done things like done industry relevant internships and will know more about technology than the PhD students usually will.
Okay, My last question is about kids. So when I was at IBM Research, I got to talk to the Boy Scout program and about security and privacy. And what they came out, the questions they asked, can you teach us how to break into a system? You know, so the question is, when we teach security, should we start with a threat mindset or attacker mindset or from a defender mindset?
Yeah, so, sorry, do you want to jump? Okay. So I love, especially when I teach people at that level, I love to take a lot of real world examples and talk about things like Bank of America has a Keep the Change program where, you know, if you go and you spend $5.23, then they round that up to $6 and they put the extra money they charged you into your savings account. But for the first 3 months, they don't actually charge you the $6. They just put the extra change in. So what could you do to exploit this? Like, and you know, then there was this guy who apparently pumped a penny's worth of gas, like for made $10,000 or something out of this. And so we had a big discussion about that, and then also talk about things like who actually really was on the hook for the bill, who paid the most money out. It turns out it wasn't Bank of America, it was the gas station that had to pay all the fees for all the credit card transactions. So there's a lot of little things like that I think can walk people through, and I have dozens and dozens of real world scenarios we go through. We play this game, what could possibly go wrong, where we talk about, you know, all this kind of stuff, and I think that helps to get people engaged and gets them to think from a different perspective. You don't want them just to have a defensive perspective or just how is this used, but how could someone misuse it? So, yeah.
One of the things I do at the beginning of each of my security classes is pose some sort of a problem, and very often it's here's what happened, here's what they did, was what they did ethical, how would you have done it, what was wrong with what they did, what was right with what they did, and so forth. And that tends to get the students into the right mindset of how do we look at things, but it also tends to get them into the mindset of asking questions about, is this something I should be doing, and so forth. I started doing this because I was in a discussion group on another class, and one of the students asked, well, gee, if people can break into banks so easily, why aren't you a millionaire? And I had to explain that, look, let's not get into the technical, let's just look at the ethical dimension of it. That money's going to come from somewhere. Ethically, would you steal the money from this person? No. Okay, then why would you do it this way? So, like that. Try to get them to think, as Justin said, think through the consequences of the actions.
Yes. So when you mention the Boy Scouts, I'm thinking relatively younger kids, and I can understand, having been one many years ago, that there might be this glamorization of, oh, I can break into computers. I think you really want to, at that age, it's really nice. It's great that they're interested in computers, but telling them these are the consequences of this kind of thing, I'm not sure that registers at that age. I might point out, okay, so that video game you like to play, it's gone. Like, you know, I removed it from your computer. And point, so it actually hits home, because I think for a lot of people, computer security doesn't really hit home until they've been hit. And especially for kids, to see, hey, you know, it's glamorous to do this, except that someone just stole these files off my computer, so maybe it's not so glamorous to do this.
One quick comment. The consequences that I tend to talk about are legal ones. For example, where Cuckoo's Egg is a good example. Randall Schwartz is another very good example. Things like that, so the students understand that, gee, it's not this professor telling us not to do this and we won't pass this class if we do. It's, wow, there are really nasty things can happen.
Thank you so much.
Hi, Steve Lipner from Safe Code. This is an old story. When back 2000 or so, I had the misfortune of running the security response team at Microsoft, which was the organization that dealt with externally reported vulnerabilities. And we had just hired, ramped up our staff some, just hired internally a new program manager to be a case manager, basically take reports from people who found vulnerabilities and drive them to resolution and solution. Good guy, well rated, not a security person, quote, somebody we had hired out of the program management team in the support organization. And I remember still bringing him, his first case, which was almost surely some buffer overrun in something, and showing him this report and the repro from the finder. And his response was, why would anybody do that? Tell them not to do that. And so, sort of my appeal, I'm not, it's 20 years ago, maybe things have changed. I'm not convinced they've changed. My appeal is sort of raise the bar, so somebody who comes out of a computer science program at least knows the concept that, a mistake in software can, somebody might actually do that, and bad stuff can happen.
This is unfortunately still common today. I've been on security panels with people like at medical device conferences or automotive conferences or other areas like that, and had people say security is just the same as safety, right? And it really isn't, because with security you have an intentional adversary that's trying to go and will manipulate inputs in whatever way they want. Whereas, I've literally heard people say you could just put CRCs or other checks like this, and them treating this as an integrity thing, because what's the chance that, the bit string is randomly going to be something that causes problems? So there is a lot of education that needs to happen, especially outside of the core. I mean, tech, finance, and even I've seen a big change in automotive with the 5 or so years I've been working closely with the automakers in there, but there are a lot of domains that still need a lot of help.
Really, really important for the technical population to at least understand that basic.
I mean, I'll make a general comment that I think, so computing is getting so broad, and even security itself it's getting really broad, and that it's going to be hard if we really accept like where this is going, sort of follow it to its natural conclusion. It's going to be hard for any of us to agree what students should know when they get their degree, because there's just so many things. It's just in a few years this community won't be able to agree on that. So what I think will need to happen is we're going to have to be more flexible with our curricula in general. So we're going to have to start doing things like 1 credit hour short courses, right, that you add on to whatever else you're taking. We're going to have to start accepting that just because you got a degree does not mean that you're done. And one of the things, and this is sort of a plug for tech, and that we are trying to have lifetime learners, and that's essentially you graduate but you never leave. And we essentially provide education as a service. So I think ultimately we're going to get to a point where you're going to get 80% of the stuff that we can probably agree on with a degree, and you graduate, and then you take a month off, and then you're back in this course learning about software automation or whatever this next thing is. So.
Thank you.
Hi, I'm Vanel, grad student from Kennesaw State University, and I'm asking this question as a software developer who's just starting to think about security. And I would just like a takeaway from here and would like to know, I heard you give an advice to instructors to tell students to, hey, think about security when coding, but I mean, that's not precise for me, so I would like just some few advice on where to start to think about security when coding. Thank you.
I'll give this one a shot. It's a tough question, as Richard pointed out. What I would suggest is first asking yourself what can go wrong, because that will get you into the mindset of looking for bugs or problems in your code that exist and that could cause problems for others. And once you've done that, then you can begin to figure out, okay, what areas should I look at? Also, don't think of it so much as what can go wrong with this program. Think of how the program's going to be used and ask the question in that environment or in that way of thinking. because security isn't really a property of a program or a machine. It's a property of program, machine, environment, procedures, and so forth. And all too often we focus on the machine to the exclusion, or program to the exclusion of other things. But basically, the adversarial mindset, adversarial mindset implies someone's out to get you, and whether or not they're out to get you, think about what can go wrong. That's where I would begin.
Yeah, and I'll even give a slightly more concrete suggestion. So what's the first program that you might learn in a language? It's probably hello world, right? If you think about that in C. So it's printf hello world. What does printf return? In its function signature, it's not a void function. It returns an integer. So printf returns a status, like an error code that tells you whether it succeeded or failed. Well, why does printf do that? Could you make it so that you take the printf example code? Can you find a way to make it so it doesn't actually print hello world? Like what situations would need to happen for that to happen? So kind of starting that exploration, even on that very dumb example I gave you, or taking and doing that with more complicated programs, because security is really all down in the weird edge cases. How do I make this really weird edge case happen? So find some case that interests you and try to figure out, how do I make weird edge cases happen? And who knows, maybe you'll be giving a black hat talk, talking about the cool thing you found.
So one of the other things I always think about, which follows on from what was just said, is think about what, if you're talking about you yourself, how can I code more securely? Think about what assumptions you're making when you write your code. I'm writing a function. I expect this input. What am I assuming is going to happen? What kind of input am I assuming I'm going to get? And so you're building these implicit trust models. I'm trusting that this is what my code is going to get, and I'm writing my code accordingly. And your code might not get that. And so a lot of the vulnerabilities we see, we talked about edge cases, and it's also about trust models. When the programmer wrote this, what did they expect they were going to see? What were they trusting implicitly? And how can I violate that and potentially change the code? So that's what you want to think when you're writing. Or one of the things you can think is, if I get an input that's different than what I expected, as with the format string bug, what can the consequences be?
A good example also is race conditions. There you're interacting with the operating system and you're making certain assumptions about the order in which things will occur. Well, what happens if what happens if they occur in a different order? Or what happens if someone tinkers with the environment so it's not what you expect? So it's a good example.
Thank you very much. Hello, I'm Nishan Bhaskar from UC San Diego. And so I guess we've had a lot of discussion about how to improve, security education in computer science and for computer science majors. But what I was wondering was what your opinions are on for other areas in which inadvertently people have just forget about security. So I will give an example in the sense that embedded systems, or IoT security is, a big problem. And one of the things that happens is what I've seen, I was an embedded systems developer. I was an electrical engineer. I did a basic C programming course in my undergrad, and that wasn't enough. I was never introduced to security. I developed systems in companies for about 3 years before coming to grad school and realizing, oh my God, that I didn't even know at that point initially what a public or a private key was. And so my question is and there are these people, and I'm talking about the firmware developers who are mostly electrical engineers or at most computer engineers, but not computer scientists or computer science grads, and then they are developing tons of these systems. So how do we spread security education in these adjacent domains?
So I've been doing a lot of work with especially the automotive industry over quite a few years. So one of the things that I did is I have created a secure over-the-update standard that in like 3 to 4 years will be used in about a third of the new cars coming out in the U.S. through a lot of integrations into major OEMs. And the reason why we did that work and did the things with that is because the systems that were being designed by folks in that space were really deficient in terms of security. And basically, I don't want people to die from attacks on their cars, right? So what it took to really work with those people is to have very clear, very detailed specification of how things go. Because what you have is you have a lot of programmers that can implement a spec but can't reason through like why the things happen. So to think of another example, there are a whole lot of programmers that could implement like TLS SSL. They could do that, yes, right? But there are not very many programmers that could have come up with the design of TLS SSL or one that's equivalently secure if they were left to their own devices. So that's, I think, part of it. Another aspect that's also really taken hold in those communities is there's a lot of different ways in which they have to test and certify and standardize code. And a lot of those development processes have also come a long way so that the normal code that isn't things that people have thought to standardize as security relevant is getting increasingly tested in many of these domains. So I think things are moving the right direction, and those are a couple ways. And if any researcher, any person in this room is interested in working with these communities, which is a lot of work, and it's not going to be a USENIX security paper every year sort of thing, but it's going to be very rewarding, I am more than happy to put you in touch with people I know and help to get you started. These are good communities to work with once you, you have to work with them a bit because you are the idiot who doesn't know anything about cars, who's coming in and you just need to spend some time learning about that or medical devices or things. But once you're accepted in the community, then they're very grateful and very nice folks.
Can I just make a quick follow-up too?
Yeah.
Because that's an interesting point you raised about, like specifically about automotive industry, right? And I guess one thing that I see is, the thing that I'm concerned about is these wide variety of like IoT devices. Automotive is great because they have very strong regulations and they have to pass through certifications. And so security auditing is something like, if they're doing a bad job, they will never pass certification. But there are so many of these, I don't know, your Fitbits and whatnot, or home automation and tons of IoT devices. And those are the communities in which so many developers are, so do you think that's more about the regulation side, or I don't know?
I think something probably from the regulation side has to change there personally, because market forces, if you get your thing used first to market is so important, and things like that are so important. Other areas like the power grid and healthcare and automotive that are much more regulated, I think there are other forces in play here, and they know they're going to build things. But I think IoT is just, consumer IoT is just a horrible mess. So yeah, I don't know what will ever make that better. I mean, one approach, if I were really going to dig in and try to do this, is I would try to make frameworks. I would work with people in the IoT space, build systems with them, and understand how to build a framework that was better and easier for them to use than what they're currently doing. So if you imagine, Ruby on Rails for IoT devices, and if you build that and it has security built in, then they'll use it. But other than that, I don't see any way to get to it.
Yeah, and so I'm actually from the ECE school. We don't have department. Well, actually, we do have one department, but we don't have lots of departments. We have schools to confuse people at Georgia Tech. So it's our students certainly get C as the programming language, and your point is a very valid point, because these are the folks that are really close to the bare metal, that are doing firmware and all this, and the challenge is significant because ideally you want to say, well, you have to require security courses. I think you should. Well, yeah, but my power systems colleague thinks that their course is way more important than security. Or at Tech, where DSP is like amazing, do I pull out DSP to put in security, right? So just think about that. And then, okay, well, a solution would be, well, why don't we just increase the number of credit hours for the degree? Well, no, you can't do that, right? Because our legislature is not going to allow us to do this. So you have all these really interesting tensions when we have this problem. And I think what ultimately we're going to have to do is, I think we're just going to have to do, at least for the time being, do more. And it's really back to my point. So you mentioned that you didn't understand public-private key security, right? If there was a nugget, if we had, a standard security course that's broken up into 30 different nuggets, I mean, you could get that or whatever you need specifically online or whatever it is for your job. But I think we're going to have to meet people where they are and not assume that they're going to be able to take this long, sort of expansive security course, which I would love. But you don't need to understand protocols, network protocols, for example, to understand public-private key security.
Yes, so to follow up a little bit on, so that was a really good description of the problems of educating people to do this, but as far as you're asking about IoT security and comparing it to airline, we're a reactive society, and unfortunately I think what's going to happen is that as more of these devices show up in homes and bad things happen, then you're going to see the regulations that Justin mentioned coming into place, and then we'll have no choice but to figure out how to build these to avoid certain problems, provided that when these problems occur, the causes are made public.
And the regulations or specifications are written properly. I would point out that every electronic voting machine is certified in one way or another, and the rules under which they're certified are completely inadequate. So in addition to teaching code, you need to look at the environment, the broader picture.
You're not describing learning policy, are you?
When I figure out what learning policy is, I'll answer that.
I will add one other quick nugget, is that also sometimes the fear of regulation can be a strong motivator too. So as you work with folks, if you're saying like, hey, look, you have this big problem and the regulators are aware you have this big problem, why don't we solve it before the regulators come in and tell you how to solve it? That also works well.
Thank you.
Thanks.
Hi, Yang Zhang from CSEC Helmholtz Center for Information Security, Germany. So I have a relatively more concrete question. So in your opinion, so what might be the difference of training a user to avoid falling for misinformation campaign and training a user to avoid falling for, let's say, phishing? This is a tough.
I guess I'll say something because everyone else doesn't want to.
Doesn't know what to say.
So there are different types of misinformation, and I think I'm not an expert in this area, I don't do research in this area, but I view, phishing is a way of trying to trick you to give up your credentials, often as part of them sending you an email or pretending to be a site. Whereas general misinformation in like the news media and things is problematic because it's there's sort of the implicit trust of journalism and other things. And I've seen from dealing with family members who like to listen to misinformation that once you get a big enough echo chamber, there's a big discussion of, well, you have your facts and I have mine. And it's like, even though there's video evidence of this thing being said or not being said or whatever, well, my people say it didn't happen. So, you kind of can't change people's minds in effective ways. Does anyone who's done research in this area? So I started off and rambled, so now Matt's going to clean up.
No, I'm going to make it even worse. I don't do research in this area either, but it strikes me that one of the fundamental differences is with phishing, the problem is well defined. Don't click on that link. And there are usually indicators, not always, but usually indicators that will tell you something odd is going on. But you have to know to look for them. With disinformation, which is, I think, what you're talking about, when you read something, there may not be anything in there to indicate to you that, hey, this is not right. There may be, depending on your mindset, you may think, well, this is baloney, but internally, it may be very consistent. And so it strikes me that it's a little bit hard, it would be harder to disambiguate disinformation versus correct information in that context. Whereas with phishing, it's generally, once you know what to look for, fairly straightforward.
Yeah, so if you're talking about, I'm definitely an expert in this topic, by the way. to follow up on this, if you're talking about how do we prevent people, for example, from falling for phishing scams, and I mean, how often do you see these things and you say, there's no way anyone would fall for this? But you know that people are, otherwise they wouldn't be doing it. And so my wife, who's an estate lawyer, so I don't leave her alone with the kids, but she deals with elderly often and talks about things that happen mentally as you get older. And, you know, she'll say, I know you take this for granted, but there's a whole psychological and geriatric aspect to this. So, I mean, how many of you can say, my grandmother or my grandfather clicked on this thing, and you're thinking, how in the world could anyone click on this? But, you know, I need my driveway repaved, and this thing came in and offered me to do it for $50 or whatever, and there's that aspect to it. So, you know, technically, that's not a technical thing. That's understanding the psychology of how we age, and that's just one example of lots of other dimensions that go into this problem.
Thank you.
Thank you.
So let's imagine somebody gets really excited about introducing computer security education throughout their curriculum in little modules that can be added to different courses. Are there resources they can go to find these? Are there other people working in this area that say, yeah, we're already in this space and we're helping to develop these things and we'd love to have help or love to have people pilot test these in their classes?
Actually, that's a great question. And so I'm going to nominate you to start the group that, no, actually, this is a great community to do that. So my experience has been that just forget about the little modules, the courses themselves, the community's been really helpful. I've had slides, I've shared my security slides with other people, and they've shared them with me, and Matt shared his book with me several years ago, and my students have used that. So I can see a group, you know, getting together a group of people who want to do this kind of thing, and just you could list things. Because for me, it's being a security expert, when I'm teaching another course and something comes up, I say, oh, there's an aspect to that I should let them know. But I don't really write it down. But, you know, maybe as I'm doing it over the next couple of years, I will actually make lists of these things that I come across, and I'd be happy to share them and you know, perhaps get some kind of mailing group or discussion group together where we could, or a website where we could post these things so that if people are interested in doing this, they could see, for example, when you're teaching this, you might want to mention that, and so on. But I think that's a great suggestion, actually.
Yeah, and there are actually a lot of resources out there that I'll kind of plug a few that I'm aware of. There's this set of resources called SEED, S-E-E-D, by Kevin Dew, is that right? Is that his name? Yeah, Kevin Dew. They're quite nice resources, and there's an evolution of them. I think it's called Cyber Trainer that I just heard about this conference. I haven't had a chance to check out. Lab Trainer? Labtainer, sorry about that. There's are also resources on something called, so Richard Weiss at Evergreen College has a set of resources that I'm blanking on the name of. They're quite, EduRange, thank you, okay. See, saved here. I put my slides and my materials up and have shared them with people. They've been used at about a dozen universities. I do think it would be great to have, though, a site, because, like, for instance, ACM for SIGCOMM had an ACM SIGCOMM resources site where a lot of people would find and use and share materials. So I would love to see something like that come along for our community and have us just plump that and other things that, anybody want to shout anything else out that I missed? Oh, of course, Deter. I mean, that's the 800-pound elephant in the space. That's great. Thank you.
NSA funded quite a bit of module development, and Towson's hosting it at Clark.
Clark.Center. Clark.Center, sorry.
Yeah, and there's a whole lot of modules that have been developed at different levels that are their educational materials available.
Great. And is it something that anybody can put things on, or are we still looking for like a site that then indexes to all the resources? Is anybody aware of that? Like, you know, the old school like Yahoo site that would point to everything for those of us who remember those days? Maybe we still need that resource out there that points that anybody can go and ask the resources to be added to. But
okay, I had a question, maybe mostly for Raheem, but for everybody else as well. So Raheem, you've done a lot of work on online education for cybersecurity, and I was curious what you think is lost by going online, if anything, or if all of us should be scaling our programs by putting them online, like as fast as possible.
So I can't just look at Matt until he takes the answer to, okay, all right, good. No, so that's a great question. I'll tell you, about 3 years ago, I was the most significant skeptic of online education. And at Tech, we started about 6 years ago, Online Masters in CS, which is ridiculous. It has 10,000 students. It's just insane. And I was completely, they kept saying, we need more security courses. You need to teach in this course in the program. And I said, nope. I mean, typical faculty member, nope. I love what I'm doing. I'm great. I teach my one class or whatever, a year or two class. Yeah, I got the notes for it. I do it I teach it in the same room, or I complain. It's perfect. I don't want to disturb what I'm doing. And I'm not sure about this whole online thing, period. So that was me 3-4 years ago. Now fast forward, of course, now I'm the director of our security online program. So they finally convinced me to do it. And what we have, I'll describe it a little bit, is that we have, we've recorded courses, so it's completely asynchronous. We spend a lot of time, there's a lot of resources for support. So we use Piazza to communicate. You guys probably do that too, but we really spend a lot of time in how they integrate Piazza with the other tools to make sure that we can communicate with our students and vice versa. So what I found that I've lost, because we actually teach, I mean, and all the security folks that you know, Winky and Tesu, others, Mustak, all of them actually are teaching. We teach the exact same course. We teach as exact same faculty members. We give the exact same exams, exact same projects. So that, honestly, that first cycle of actually teaching it and giving all the same stuff to the folks online, on campus, and then realizing that the averages were the same or very close, that honestly convinced me. So I wasn't convinced until I actually did it. Now I'm like, huh, this thing actually works. What I miss is what I'm getting right now, which is like reactions from people in the audience. And when I teach, I really love to read my students' faces, and really, if I have time, you can quickly tell that people don't understand or they're not paying attention, and you really can make that classroom environment much more engaging by getting that immediate feedback. So I miss that. I mean, I think that we can't get that back, but we gain so much. This program, actually, our programs, it's very different. It's pretty much a social science experiment too. So we've written papers about our programs, but the average student is like 35 to 37 years old. Half of the students already have a graduate degree. Many have PhDs. So what happens is, during this Piazza discussion, you're no longer the only expert. So they're actually, 15% of the class, they're actually also experts. So now I learn more stuff, as well as the other students, because you got people that work for 20 years in process control engineering that are now taking my cyber physical system security course. So we lose some things, but we gain so much in that it made us double down. So we created a OMS CS program, then OMS Analytics, Online Masters is OMS, and now we have this OMS cybersecurity program.
So I'll just piggyback something on there, because we also have a large online program, and I'll just speak more from the instructor perspective as someone who's been recording and been on the other side of this a bit. So, and I know our process at NYU is probably has some differences with Georgia Tech, but it was definitely a lot of work to go and put this together and do quality control, but it was very rewarding. And if you put good work in, then the students do really enjoy it and do really get engaged. The scaling the assignment is something you have to think a little more carefully about, because it's no longer a problem of just threaten the TAs more that you'll take away their stipends if they don't get the grading done, or I don't know. I've never had to do that. I'm just trying to joke around, but if you design your assignments and design your modules well and have really good course creators, then the whole process is a lot smoother than you might think, and the quality is still very high.
Anyone not like online courses who we have here? Okay, no. Great. Luca?
I think online courses are great, and certainly at a place like Richmond, we think about, will there be colleges in 10 years that you actually have to go to? So, and in fact, I've used a lot of online courses myself, and materials. I'll contact the instructors and say, hey, can I use that material to teach my students here, some of my research students? And people, yeah, sure, you sign them up and do this. It's great. The things that you miss are, as you said, the personal interaction, working with research students. I get to know how they work, how they deal with certain kinds of pressure. I get to know how they work with each other. And so, but most important, and maybe this will be irrelevant in the future if we go to this, but a lot of aspects of CS deal with working with others. And when I write a letter of recommendation for a graduate school, I remember when I had my postdoc at Maryland many years ago, I had 70 kids in the class and 3 TAs, and I could say, student X got an A in my class, the grade distribution was this. That was about all I could say. When someone at Richmond asks me to write a letter, I can talk about, I've worked with them for 2 years, this is the way they are, they're punctual, they're friendly, I can task them with these kinds of things. These are things that I couldn't get in an online scenario. So this is not a critique of online universities. I think like many other things, they serve a really good purpose and do a lot of good, but I don't know that they'll replace traditional education, or I don't think it will.
Thanks. Luca?
Hi. Hey again. I didn't want to hijack the conversation, so I sat back, and now I'm here again. Mostly because I was not very satisfied with the answer that I got, right? And I think that partially that's because I've been a bit sloppy with how I formulated my question in a way. So allow me to get back again to that offensive part of the discussion. Because, computer security, and we've seen also today, right, has been around for just about as long as I've been, right, about the 1980s, started being integrated into computer science courses, and it's been, been also academically been of an afterthought, because when it started gaining a lot of momentum, then we realized as a community that we need to add these courses on computer security in computer science majors. Now I think that with the offensive side, we are a bit in the same moment where we're starting to realize that yes, building secure software is extremely important, user awareness is extremely important, but we'll never most likely get to a point, at least because you can always fool a human, that a system is completely secure. And so the other tension part, the one where you actually have the attackers that compromise the systems, is gaining a lot of momentum as well. And so my question is, and also goes back to your answer before, is that everybody is teaching a little bit of red teaming, a little bit of penetration testing, etc. But from my perspective, I think that the curriculum of a pen tester is extremely different from the curriculum of a person who builds secure software, for example. Think of social engineering techniques, or think of the art of deception, or things like that. These are not things that a software developer to build secure C code needs to know. So if we need to build, and this goes back to the first point of Elissa at the beginning, where should computer security stand at academia versus industry level? How integrated should it be? If we need to build real pen testers, people that are really capable of getting into systems, from reconnaissance to reporting to social engineering to integrating with technological attacks and all that, we need to train them. And if we just teach one offensive computer security course, or we have a red team challenge in a major, is that enough? Or we need to start thinking of changing a little bit the way in which there is a course on defensive techniques and there is a major on offensive techniques, and keeping these things talking to each other, but separate and specializing in these things. I think this is more comprehensive. Yeah.
So a lot of programs like ours have we have a separate offensive security from penetration testing class. And we have multiple different classes that are more in like defensive application security and so on. But from a fundamental standpoint, in the beginning, you do have to start with people understanding threat modeling and understanding the way in which attackers might attack systems. So there will, I think, as you rightfully point out, always be some overlap. Students tend to self-select themselves into, do I want to take all the offensive classes? Do I want to take mostly defensive classes and blockchain and whatever else, and not do this? But in order, actually some research we did showed that defenders, in order to be good at defense, you have to be able to understand effectively how to attack, or at least the students that were good at defense were also good at attack. Because you have to think about what can go wrong and understand this. So that perspective, I think, is valuable for everybody. But you're right that maybe we don't need every student that's going to write defensive code to go through an 8-course sequence on various levels of penetration testing.
Well, and also, I mean, if I understood your question correctly, you were talking about there are all sorts of other aspects of things. There's the social engineering aspect. It's a very vertical thing. And my thought was, we're not going to turn out students who are prepared to go right in there and do everything they need to do. I liken it sort of to a professional athlete, the rookie professional athlete who you can go through training camp and you can learn the moves, but until you're in the game, you're not going to learn certain things and no one's going to teach them to you. And so we try to prepare them as best we can, but ultimately doing the job is where they're going to really gain the experience. I mean, experience actually means something to know all of the things they have to do. I don't think any education is going to plug every single hole that needs to be plugged.
Yeah, and so right now we're talking about primarily CS programs. I mean, that's what we're putting out, and then they will get little nuggets here and there as security courses. And there are only a handful of security undergraduate degree programs in the country. So I think, at least in the U.S., so I think you have a valid point. And as we move to undergraduate security degrees, if it's as the market demands for that, then I think you will see more specializations within security. But right now, we're in computer science or ECE, and then it's folks that have a few security courses, and then they're taking the offensive course within that. And I mean, pen testing right now is still very niche, right? So I don't think you would have a path, if you will, for that. But I see it evolving to that. Honestly, so at Tech we have, one thing I like about Tech, and I'm just a shout out to the College of Computing, which I'm not in, is they have like 13 different threads. So it's 13 different flavors of the computer science degree. So if you're really interested in being close to hardware or algorithms or security, then your CS degree is tailored according to this thread, which is really neat. Well, imagine as time continues and security continues to broaden, which it will, you have something very similar, and you have this pen testing thread that has the military science type courses in it and all the other sociology and psychology. I mean, I see that's coming, and it makes sense, but I don't think a university, a trade type program would do that, but a university would not be ready to commit to something like that, I would think, in the immediate future.
Thank you. Okay, I wanted to close out our panel, which is titled Security Education, with a question about not cybersecurity, which is most of what we've focused on. So we also have a lot of other topics that come up at this conference, like privacy, as well as sometimes e-crimes and harassment and stalking and partner violence and so on and so forth. And that's, at least in my experience, often not a topic in our security courses, either technical privacy or what do I do if this happens to me? So is that something you guys have addressed, or do you have sort of food for thought as we leave the panel about how we might think about adding those issues into courses moving forward?
So I mentioned I have this like what could possibly go wrong part of the class that I talk about, where I talk about real world examples, and I do actually talk about some of those types of issues. Maybe obviously not going into the same level of depth and things like that as the excellent speakers here, but I do think it is absolutely something that people should get some exposure to and know something about. And having real world examples like that maybe a friend or their cousin or something went through. Hopefully not them, but I think also helps students to connect and can be a better way to really draw people in and get them to care about the topic.
When I talk about confidentiality, I also talk about privacy because of the control aspect of it. Slight distinguishing. As far as the others go, I know our university has an introductory course that students get in the summer that covers a lot of that. I also use them as examples at the beginning of class, but I don't go into any kind of depth about them.
Yeah, as I said, aside from certainly my regular courses, I talk about what can happen, but it's really the sort of roadmap course that I teach during the summer for a few days where I'm talking about privacy, and I'm getting across to them sort of what information is out there about you, which actually I did an experiment some years ago where I gave one of my students, it was actually a high school student who is now a student, and I said, you have 2 hours to find out everything you can about me. You can't pay for anything, you can't break any laws, you can't hack anything. And I got to tell you, I was astounded by what he found. So I point this out.
Try giving that to a class of 100 masters and undergrads, as I did my first semester. It was interesting.
Yeah. He was telling me things I didn't even know. The name of the doctor who delivered you was, and I was like, wow. And he gave me like my last 20 addresses. I was like, but the point is that we do talk about some of those issues. As far as other things, which are important, such as if I'm the victim of one of these things, what do I do? I'm not sure I know the answer. I mean, I was a victim of the Target. I think actually my wife charged something, and so we were one of the folks that, and we sort of played it by ear and had to figure out as we go. I wouldn't be qualified to teach that. And I'm not sure a CS course would be the place to teach it either. It's sort of like a life skills course these days.
Yeah, I'm going to take the easy way out and say I haven't taught the undergraduate course where I think it would be appropriate in 3 or 4 years. But I think it's important, and it makes sense for it to be in there. But I'll take a cop out.
Okay, thank you. Thank you all for joining us, and let's thank our speakers.